and thank you for inviting me to come and talk this afternoon. Sustainable servo motors, servo drives. Haven't got time to do the full hit, so this is going to be a bit of a whistle-stop tour and glossing over loads of stuff, but hopefully give you loads of enthusiasm to go and look at this really important topic. ZF, in case you weren't aware, one of the largest automotive suppliers. And I'm based in the new building in the top right corner in Solihull. Climate change and effects there, and lots of aspects to look at, and different scopes of carbon, whether it's where the energy is coming in to make things, whether it's in transport, moving goods around between factories, or whether it's in the energy that goes in to actually making a product, or the energy and the carbon that's consumed in use. And I'm going to go into more about the product aspect this afternoon rather than the others. As others have mentioned already, and some of the numbers that Michael had on the slide around the targets and the timescales for electrification, 2030 for vehicles in the UK being hybrid or fully electric. Rewind back to after you get things going into production, development, it really says that it's not long away at all in terms of development cycles. And 2035, only electric. So a lot of activity around electrification, but it's not just traction machines. There's all the other actuators in vehicles as well, whether that's steering, braking, roll control, and others. So lots of motors and electric drives coming along. Hierarchy of sustainability, as when people think of sustainability, thinking about, often they jump straight to the bottom to recycling. And I invite you all to stop a little higher up on this and see if we can keep more of the carbon and the energy and the materials that go into products in those higher levels. And I'll dive into a few of these different aspects now. And thinking about reduction first. How can we, first off, reduce the amount of material that goes in? And if we can do that, then we should reduce the environmental impact. So things like housing optimizations, and as Magnus was talking about, just with structural optimization. Okay, well, combine that with mass reduction, looking also at vibration modes, get the weight out through lighter housings. Obviously, the usual things around just making sure machines are the right size for what's needed. We saw earlier about hollowing out bits of magnetic circuits, putting in thermally conductive materials, get the heat out, make it so that the machine is going to be able to work at the level that's needed, but with better thermal distribution. The motor that's on the screen there has got a lead frame within it, and obviously that takes up space. What if you can get those out? We've got some other products I've got some photos of later where you can see that the lead frames and the space, the inactive space that's in machines being removed. Again, things like sensor integration and removing sensors, putting more functions in software. Do that. We can make the machines smaller, less material going in. And then, what about a different approach? Eliminate motor housings and put the active components straight in to a bigger application. Okay, so this is then going to precipitate a whole load of activities, because now we're putting components directly in, so we've got to test those components at an earlier stage, and you can't test the whole machine till it's fully integrated. So control of process has got to be that much more involved. But you are reducing the transportation because everything's going to where the machine's finally being set up. But you have got to have pretty good control of that process. Another example of how we could reduce use of material, just go faster with the machines, make them smaller. But of course, with this, then comes issues of containment, making sure that everything's going to stay there. And I know that within the FEMM hub, people are looking at containment of rotors and other aspects. And that's, you can see where it's fitting in on an approach of reducing material that's going in. And again, there can be all the other issues around if you start to go faster, you've got mechanical efficiency problems because you've got to keep the same output at the end. You've got audible noise and some losses to think about. So lots of trade-offs with these. If we start to think about some of the other words that were on the table earlier, and just before I go into remanufacturing and repurposing, just a selection of components and fully assembled electric drive. So bottom right corner, very integrated motor and electronics. Above it, just a rotor, surface permanent magnet rotor. Various components there at different levels that are assembled and potentially disassembly. So remanufacturing, for those who don't know, that's where a part is taken back, taken apart, serviced, parts refined, replaced as needed, and products put back together and put with a guarantee back out into the marketplace in the original use case. Repurposing is where you take something from one area, say automotive, and put it into a different setting, or vice versa. And if you're going to be getting involved with these, obviously you need to understand component aging and wear, and think of, say, something like bearings. How, on a shaft, how do you get that apart if it's being pressed on? And things like seals. What sort of seals? Is it possible to, say, make the machine so it doesn't need seals in the first place? Coatings, there's an example there of magnets. But coatings and what happens over a long lifetime. Similarly, things like insulation. And of course, connectors are always one area. So this morning, where Diva was talking about some of the connection type issues, may well be also a role to play later in a product's life. But of course, understanding what you can do with parts later on is understanding the quality of them. And again, this is where data, that was also being talked about today, can come into play. So obviously you can test the product and components when they're being made. You can condition monitor in the future as products are in use. And then start to compare and look and see if parts are able to be reused, repurposed. And all sorts of stuff there as to whether it's being done locally, whether it's being done in the cloud, what signals, and what test equipment you might need. And also think, with all the robotics that are within the hub, how they could be coming into play with keeping parts going, not just for their first life, but also as they could be redeployed and reused. SUSMAG Pro, a project which we're involved with 19 other organisations around magnet recycling. So this is taking magnet material from a range of sources, whether it's wind, hard disk drives, electrical machines, robotic sensing to find out where the magnets are, 3 pilot lines and production facilities to get the material back. And then the bit that I'm particularly having a look at has been around the design for recycling and the design for use of recycled magnets, because the properties of recycled magnets might well be different. And therefore, the operation and the optimization points could well be different. And of course, as you go to try and get things to be recycled, you've got to think, what else is in there? And is that going to contaminate processes? The energy that's involved in doing this. And lots of different methods of recycling. And the methods are probably quite important to think about, because are we going to have in future labels on products, a bit like we have on clothes to tell you how to wash them? Are we going to have labels that tell us how to recycle? Or is it going to be parts taken to one place, so centralised or localised? Can you do it with standard tools? What can you do with automation? How is the volume of parts going to affect this dynamic? Loads of things to be thought about and worked through. Quick example. 2 types of rotor from permanent magnet machines. One of which, nice simple block-shaped magnets with the flux path largely being determined in the air gap by the shape of the iron. The other one, very complicated, perhaps shape of arc magnet or bread loaf, glued into place. What does the glue mean for getting things apart? But a lot closer to the surface and perhaps more accessible. What could you do with each of those? If you could get the magnets out of one, without having to, with a block shape, you can perhaps reuse those without putting them back to a powder. The other rotor, much more complex shape, might limit what can be done. So a whole load of things to think about and trade-offs as you start to assess possibilities for sustainability. Another example, more mechanical one. I'm sure we've all seen these snap fit fittings, where you take a plastic part, push it together, click, it's fitted in. It's obvious if it's there, tamper evident, you're going to break it if you take it apart. It's one material, one set of tolerances, low-cost tooling, but you can't get it apart when you want to service it. So what about, not saying this is the right way to do it, but a way for illustration. Put some screws in. So we've now gone from a simple click fit to something with 3 screws. Probably need some anti-vibration washers to stop it rattling loose. Probably need a label as well, so you can see if it's been tampered with. Probably need the machine to check that all the screws and the labels are in place. So then you've got to have the extra space on the line, more tolerances now to think about, and so it goes on. And all these one change to make something more sustainable and serviceable has precipitated all of this. So things we've got to think about at design time, not later on. Thinking then about operational carbon, so the energy that's being used in use. Maybe sometimes it's better to put a bit more in the product or in the system so that it is more efficient when it's being used. And assessing that and that balance. Also, a lot of people just think of sustainability around carbon dioxide in the air, but also material selection is very important, and how those materials are coming, how those materials are themselves being made. So multiple issues to be thinking about. And of course, if you go and change from one type of machine to another so that maybe to avoid a particular material or activity, then you're still going to achieve the same thing at the end. And it's still got to meet all those safety, performance, packaging, power, inertia, environmental, but all that big long list. So this addition of sustainability is, I think, going to give us all challenges to think, how do we build it into processes? Another example with, on the right there, assembling that stator into the housing. And a few ways you could do it. One, heat up the housing so it expands if it's aluminium and drop in the stator. Another one, just press it in or use some adhesive. Different amounts of energy needed. Chemicals that may well cause contaminations of recycling processes. Trade-offs again. Different ones may affect the way that the stator teeth and the shape and therefore harmonics that results from it. All sorts of aspects. And again, looking at different winding methods and what they're meaning and the flexibility for sustainable design. Big area, I think, there to have a look at. So to draw things to a conclusion, I think we've got to design in sustainability. We can't just sort of do it at the end because of all the changes and the issues that we need to be thinking about, the trade-offs. Because as I said, we've got to meet all those requirements we have already, and we want to be able to have much more sustainable products. Thinking about the balance of the embedded versus operational carbon. Where should material be put? I haven't really talked about this as I've gone through, but modularity, I think, is pretty important in terms of breaking the motor, and particularly with the electronics, down into subsystems, which you don't necessarily need to know what's inside each one, but you need to know what it does, what the interface is, because that then allows much more interoperability or use or servicing in the future. And with that goes documentation and knowing what to do and how to go about working with parts in the future. You think of things that have been around for 10 or 15 years now, and you go and look at it. Have you got all the information you would need to really know what to do? So, lots to think about. Loads of work. It's an exciting time, I think, to be working in machines. With the challenges of sustainability, so much more for us. But also the opportunity to really create altogether better and more sustainable motors, servo drives, and the electric drive units. So thank you very much for listening, and take your questions.